Hello everyone, a very good evening. Welcome to the GATE 2026 Score Booster Series. So in this session, we are going to discuss about the open channel flow. And in case of the open channel flow, for GATE point of view, this is very small subject, but heavy weighted subject. You can expect minimum to minimum of 3 marks to the maximum of 4 marks. And most number of questions from this topic will be coming as either MCQ or NAT. Less number of questions will be coming from the MSQ, but still we'll try to cover the MSQs and NATs. So now see the first question. This is an NAT which is based on the hydraulic jump. A hydraulic jump occurs in a wide rectangular channel with the initial and sequent depth of 0.5 meter and 2.5 meter. Initial means before the jump and final means after the jump. So after the jump, that is 2.5 meters respectively. So the energy loss in the jump is, this is a one more question. So straight away delta E is equals to y2 minus y1 whole cube by 4 times of y1 and y2. So the delta E is equals to, you substitute 2.5 minus 0.5 whole cube by 4 into 2.5 into 0.5, right. So if you see 2.5 minus 0.5, which is a 2 cube is 8. So 8 by 4 into 2.5 into 0.5, which is 2, right. And this is going to be the 0.5, it will go to the numerator 4. So now it is going to be 4 by 2.5. If you solve, what is this value? 4 by 2.5. So that comes as 1.6 meters. So how much amount of the energy that is going to be lost over here is 1.6 meters. But sometimes, so they are asking rounded to 1 decimals, right? 1.6 meters directly. But sometimes instead of asking the energy loss, the examiner will be asking you the power loss also. So at the time of the power loss, then if I would have asked you the power loss, then delta P is equals to gamma W into Q into delta E. But that requires the discharge. So how to find out the discharge? In the same question, if I would have asked you 2 marks question, so I'll ask you that how to find out the discharge. You know the relation between the sequent depths, Q square by G is y1 y2 into y1 plus y2 by 2. So you know y1 y2, you substitute, you will be getting that discharge per unit width. So you can substitute that small q also, then you will be getting in terms of kilowatt per meter. So for 1 mark question, we can expect as energy loss. But if it is a 2 marks question, they will be they'll be asking the power loss also. So first you need to find out the energy loss and then you need to find out the discharge also, as you know y1 and y2. So now that's about this question. Now if you see this question, this is an MSQ. In a specific energy diagram for open channel flow, select all the things that can apply, which is nothing but the MSQ. Okay. So if you see, if you look into the specific energy curve, so whereas E versus Y, now whatever this line we call it as a potential energy line, right? And if you look into the curve goes as, looks like this, where whenever this is a E minimum and whatever the depth corresponding to this is a critical depth. So let's see the options which are going to be correct. There are 2 depths of a flow for a given energy except at a critical depth. Yes. So for a given energy means for a given specific energy. So if you see for a given specific energy other than E minimum, if you drop, there exists 2 depths and those depths we call them as alternate depths. So statement number 1, A is correct. Then the curve intersects the vertical axis at a height equal to the flow depth. The curve intersects the vertical axis at a height equal to the flow depth. No, the curve will not going to be intersect anywhere. The curve is going to be asymptotical to the potential energy line. The curve will not touch the y-axis. So this is not correct. The critical point represents the minimum specific energy. Yes, whatever the critical point you see, that we will be getting as a minimum specific energy. So that C is also correct. Now, the curve is symmetrical about the critical depth. Is it symmetrical about the critical depth? No, you can see above the curve is different, below the curve is different. That is not a symmetrical curve. That's a 3-degree parabola. It is not a symmetrical curve. So it's not a C shape. So it is not symmetrical about the critical depth. So that's also not going to be correct. So now if you see over here, so the correct answers over here are A and C only. The correct answers are A and C. Okay. We can also prepare the similar kind of question for based upon the Q curve also. We can also prepare the similar kind of question for F curve. In case of F curve, the critical point represents the curve is symmetrical about the critical depth. In case of F curve, it is symmetrical. But in case of E curve, it is not symmetrical. Okay. So now, let's see this one more question with respect to the like MSQ itself. Which of the following factors affect the critical depth in a open channel? In a open channel. So it's about the critical depth. Okay. Now, if you want to understand this, at a critical condition, Froude number Fr is equals to 1. And what is the critical flow condition? Q square by G is equals to A cube by T. Right? Now, which of the following factors affect the critical depth in a open channel? Discharge, yes, definitely. If discharge changes, critical depth is going to be changes. Channel geometry, yes. Why? Because for different channel cross sections, different critical depth is there. Because if channel geometry changes, area and top width also changes, the critical depth is going to be changes. Channel slope, see, the critical condition is independent on slope. It is never dependent on the bed slope. That is independent on the slope. And last one, Froude number. If Froude number changes, that critical depth changes? No. Critical depth is going to be occur when the Froude number is 1. So Froude number is constant. There is a constant value. So critical depth is, Froude number value is going to be constant. The critical depth may be 2 meters or 3 meters, but they will be occur at a Froude number is equals to 1 only. So again, in this, the correct answers are A and B. The correct answers are going to be A and B. Okay. So yeah, which of the following factors? That is again an MSQ question. Okay. And if you see one more MSQ, then we can solve the remaining NATs also. Now, you see, which of the following is / are correct statements? So, what are the correct statements? In oscillating jump or hydraulic jump, so they have given the Froude number. We are going to classify the type of jump based on the inlet Froude number. So, what is the inlet Froude number? The Froude number of the supercritical flow, which is before the jump. So, based on that, whenever the Froude number is 2.5 to 4.5, what is the type of jump? It is an oscillating jump. 1 to 1.7 undulating jump, 1.7 to 2.5 weak jump, 2.5 to 4.5 oscillating, 4.5 to 9 steady, and greater than 9 is a strong jump. So, from the given options, this is correct. Yes. Next, the upper portion of the specific energy curve is asymptotic to the potential energy curve. Yes. So, if you look about this one, this graph, you see the upper limb of the specific energy curve that looks like asymptotic. So, what is mean by asymptotic? It seems to be touching that line, but it won't. So, this E curve is going to be asymptotical to the potential energy line. So, right? So, now this option is also going to be correct. So, first one is correct, second one is also correct. But what about the third one? The dy by dx. The dy by dx is equals to S0 into 1 minus yn by y whole. See, now they have given the whole. No, it is not like this. So dy by dx is equals to S naught into 1 minus yn by y whole power 10 by 3, but not for the whole bracket, divided by 1 minus yc by whole cube. So it is not 1 minus yc by y for the entire thing, it is a cube for only yc by y, which usual notations is the differential equation for gradually varied flow in a small open channel. First of all, that equation, this equation is for the wide rectangle, not even for the small open channel. So even if they have given that wide rectangle, that equation itself is not correct. So this is incorrect statement. Now critical velocity in a rectangular channel is given by root of 2gy. Is it? So what is the critical velocity? The critical velocity is root gd. In case of rectangle, that is a root gy, not root 2gy. So the D is also incorrect statement. From the given options, the correct statements are A and B only. So the correct statements are A and B only. Okay. Now let's see some of the like NAT questions also. Okay. Now, if you observe here, what is the question that is mentioned? A 3.6 meter wide rectangular channel, a 3.6 meter wide rectangular channel carries a water at a depth of 1.8 meters. So what is the depth? 1.8 meters. So in order to measure the discharge, the channel width is reduced to 2.4 meters. Channel width is reduced to 2.4 meters. So initially the width of this rectangular channel B1 is 3.6 meters. And that is going to be reduced to 2.4 meters. 2.4 meters. Okay. Now, before this transition, whatever the depth of the flow, the initial depth of the flow is given as how much this is? 1.8 meters. So y1 is given as 1.8 meters. Okay. Now a hump of 0.3 meters is provided in the bottom, which means it's a double transition, right? So a hump of 0.3 is proposed. So delta Z is given as 0.3 meters. Okay. Now what they're asking is calculate the discharge if the water surface in the contracted section drops by 0.15 meter. Which means here is the water level. After the contraction, this is the water level. So now the water level is going to be falls by 0.15 meter. So the drop in the water level is 0.15 meter, right? Now whatever the remaining depth, this is a y2. And as there is no losses much, so we can see whatever this line, this is known as the total energy line. What's the question they are giving? They gave width, they gave depth and all. The question they are asking is about what is the discharge. So if you observe, whenever we see a question regarding to the transition, whether it is a single transition or double transition, whatever it is, first try to write down the relation between the specific energies. So if you see before transition, this is the specific energy E1. After the transition, this is the specific energy E2. So now come on, tell me what is the specific energy over here. So if you observe, the specific energy is nothing but E1 is equals to E2 plus delta Z. E1 is equals to E2 plus delta Z. So what is E1? y1 plus v1 square by 2g is equals to y2 plus v2 square by 2g plus delta z. Okay. Now I have y1, right? What is y1? 1.8. I have y2, then I need to find out the y2 value. So, and I have delta z. What is the delta z? 0.3. You see the figure carefully. How to find out y2 value? How to find out the y2 value? You see here. So, y1 is 1.8. What is this y2? Already water level dropped by 0.15 and bed got raised by delta z. So, I can write that as y2 is equals to y1 already water dropped by bed raised by delta z and water dropped by 0.15 meter, right? So, now 1.8 minus bed rises by 0.3 minus 0.15. So, which is 0.3, 0.15, 0.45. So, this is nothing but 1.35 meters. So, y2 is 1.35 meters. So, once we know that, then I can write down, and now I know the y1, I know y2, I know delta z. But what we require? We require discharge. Do we know the velocities? No. But can we find out that velocity as a discharge by area? Yes. What is area? And given is a rectangular channel only, right? So, what is the area? A1 and A2. So, what is the area now? You see, we can write down V as a Q by A, right? So, first we need to find out the A1. What is A1? B1, Y1, right? So, come on, what is B1? 3.6 and what is Y1? 1.8. So, 3.6 into 1.8. So, solve it. 3.6 into 1.8. That's going to be 6.48 meters square, right? See, I want discharge, so I am writing velocity in terms of discharge. And what about the A2? The A2 is B2, 2.4 into Y2. So, B2, Y2, which is 2.4 into Y2, 1.35. So, this value is 3.24 meter square, right? So, now what we do, we'll just solve it. y1 plus v1 is nothing but q square by 2g a1 square is equals to y2 plus v2 square q square by 2g a2 square plus delta z. So, y1 is 1.8 plus q square. So, we will do one thing. We will bring the q square by 2g terms on one side. So, now if you bring that q square by 2 into g, g is nothing but 9.81 on one time, 1 by a1 square, 1 by a1 square, 6.48 square, bring this also minus 1 by a2, 3.24 square is equals to, now you can see this as yes, we can do the reverse, that's not an issue. So, what we can do is we will send that to the other side, then this is nothing but 3.24 square minus 6.48 square, okay. So, now you are sending a1 to the other side, now bring that y1 minus y2 minus delta z. So, what is y1? 1.8 minus y2 1.35 plus 0.15. So, if you solve it, the LHS, RHS, 1.35 plus 0.15, 1.5, 1.8 minus 1.5, that's a 0.3. So, now whatever this equation, so come on, answer to me, what is the value on the LHS, please let me know. What is the answer to me? I mean, what is the value on the LHS? Let me know, please, everyone. Come on, calculate. Come on. Need your answers. So eventually, if you solve this, you will be getting this as a q square into 0.00364, and if you get this answer, so whatever this value, after solving, you will be getting that discharge as 9.076 meter cube per second. So now first thing first, whatever the transition they have given, what you need to do is first you draw the figures in the plan view and in the section view, and once you get down that figures, then you write down the relation between the specific energies. So once you know the specific energies, then you can find it out, right? So it's a simple calculation. The answer is 9.076 meter cube per second. So that's about the double transition. Now let's see this question. Actually, this is a very good question, because in the recent times, so the examiner is trying to ask you not only with the standard sections like rectangle, triangle. So they're asking the questions with respect to the rounded sections by adding the corners. So in GATE 2024, they asked in set 1 and set 2 with a triangle with a rounded bottom. So as it's already asked, now we'll be looking about a question with a trapezium with a rounded bottom. Okay. So a standard linear trapezoidal section. So now that's a trapezoidal section has a bottom width of 35 meters and a side slope of 1.5 horizontal to 1 vertical. So the longitudinal slope is given, B is given 35 meters, longitudinal slope is given 1 in 5000, and Manning's N is given as 0.016. So what I'm asking you is a discharge for a full supply depth of 3.5. See, similar type of question has been asked in GATE, but they have asked about the triangle. What is the change is a trapezium with a rounded bottom. If you see the figure carefully, so observe here, whatever the angle that is going to be there present over here, this angle theta, there is a theta, right? Angle theta, and that angle, see, this angle is 90 degrees in between these two. If this is theta, then what is this? 90 minus theta, right? And if this is theta, then what is this angle? 90 degrees only. And if this is theta, the outer angle is also going to be what, Ray? Theta. So that is what they mention. So the outer angle is also going to be theta. And whatever the radius is given as y0, and whatever the depth y0 is nothing but how many meters? 3.5 meters. So everything is given over here. Now what you need to find out is discharge. So to find out discharge, what to do? As per Manning's equation, Q is equals to A into 1 by N into R to the power of 2/3 into S power 1 by 2. Now I know N, I know S0. I need to find out area and I need to find out the hydraulic radius. So to find out the area and hydraulic radius, first, what is the area? So now if you see this figure carefully, so now you see this is R and this is also y0, na? That's also y0. And whatever this angle is 90 degrees, right? So now if I ask you this value, so what is this value? What is this value? You tell me. What is this value? I can use this value, this theta, and can I use the tan theta is equals to opposite by adjacent or not? So whatever this is inclined and this is nothing but an arc. This is nothing but an arc. So for wetted perimeter I need this inclined, this is arc, this is base width, this is arc length, again this is the inclined, right? So now let me take this as a arc length L bar, arc length as L bar. So now this is also arc length as L bar, and whatever this is inclined. So first how to find out the inclined? Now what is the inclined? You please observe that inclined value. Tan theta is opposite whom? Y0, because the full supply depth is given as Y0. Y0 or Yn both are known as normal depths or uniform flow depths. So from there tan theta is opposite Y0 by I. So I can write Y0 into cot theta. y naught into cot theta. And anyways that y naught cot theta is nothing but m value, which is nothing but cot theta is how much? 1.5. Because they have given that, na. Now you see this, tan theta is equals to 1 by m, and m is equals to what? Cot theta only. So whatever this value is given as 1.5. Just to keep it like that, I. Now once you know I, then what is L bar? L bar is now, you know, for a sector, right? So whatever this L bar, this is nothing but theta. So what is that? So if you know the angle, what is the length of the arc? R theta, right? So that's nothing but R theta only. Now if you observe over here, this is nothing but L bar, which is nothing but R theta. So if you know this, then let's find out the weighted perimeter first. What is the weighted perimeter? 2 times of inclined plus 2 times of L bar plus width. So now 2 y naught cot theta plus 2 r theta. What is r theta? Y naught theta, right? Because r is given as whom? Y naught only. 2 y naught theta plus b, right? So the weighted perimeter I can write as b plus 2y into theta plus cot theta. Any doubt? Right. Now similarly, what about area? Area is nothing but, you see, there is a rectangle, there is a triangle, 2 times of triangles. First rectangle area. The rectangle area is by naught plus, what about the triangle area? The triangle area, so first let's find out the width value itself directly, then we can find out the area. Let's find out the weighted perimeter. So you know, now m cot theta, that cot theta is nothing but 1 by 5. And what about the theta value? So tan theta is equals to 1 by m, right? Then theta is equals to tan inverse of 1 by 1.5. Check this value. One by 1.5, you will be getting that as a 33 degrees, 33.69 degrees, but we want in terms of radians, right? Into pi by 180. Pi by 180. So this is going to be 0.589. That's going to be 0.589. Okay. So now once we know, then substitute over here. P is equals to 35 plus 2 into 3.5 into theta 0.589 plus cot theta is nothing but 1.5. Substitute. Plus 35. So answer is 49.62 meters. Okay. So this is about the weighted perimeter. Now similarly find out the area. What is area? Rectangular area by plus triangle area. What is triangle area? Half into base into height. Half into base. What is base now? Y naught into I. So 2 times of triangle, half into base. If I take base as y naught, what is I value? Y naught into cot theta. Y naught cot theta plus sector is there. So this is nothing but theta, right? If you know, for total angle 2 pi, if you take a circle, for total angle 2 pi, what is the value? Area 2 pi, pi r square. 2 theta, theta r square. For 2 pi angle, pi r square. For 2 theta angle, theta r square. For theta, theta r square by 2. So the area of this one is theta r square by 2. But how many are there? That sectors are 2 sectors are there. 1, 2. So now plus 2 into theta r square y naught square by 2. So 2 will get cancel. Here also 2 will get cancel. Then I can write area as by plus, can I take y naught square common? Now y naught square common plus theta plus cot theta. Now substitute by, here y naught, 35 into 3.5 plus 3.5 square into theta 0.589 plus 1.5. So tell me this answer. Just see, if you understand the wetted perimeter, if you understand the area, how I am finding out, then that's it. You get this, then you are going to apply the equations only. So this is going to be 148.09 meters square. So that's about the area, and in the case of the wetted perimeter, once we know this value, then simply substitute. Q is equals to area 148.09 into 1 by n 0.016. Is it? Yes. What is R? A by P. 148.09 A by P 49.62 whole to the power of 2 by 3 into S naught. What is S naught? 1 in 5000 whole power 1 by 2. 148.09. So now you solve this. One 48.09 by 49.62 whole power 2 by 3 into 1 by 5000 whole power 1 by 2 into 148.09 divided by 0.016. So you solve this, whatever the discharge that is going to be carried is 271.33 meter cube per second. That much amount of the discharge you are going to calculate. See, my point is not about this application. My point is you to understand how to find out the channel geometry details. If you can understand how to find out the channel geometry details, no matter whatever the question they give to you, you will be able to answer that. So now we have solved the questions with respect to the linear canals, and we have solved a question how to determine the, for a critical depth, and we have solved the questions with respect to the transitions also. Now one more question we'll solve. So with this we are done with the session. So a wide rectangular channel. So now they have given the wide rectangle is carrying a flow as 2.76 meter cube per second per meter width. The depth of the flow being 1.524. So initially the depth is 1.524. The minimum rise in the floor at a section required to produce the critical flow condition is. What is the minimum rise to create? What is the minimum rise to produce a critical flow? Delta Z C. So delta Z minimum is nothing but delta Z C. Given is Y1 how much? 1.524 meters. And whatever the Q value is 2.76 meter cube per second per meter. Now what about the relation between the energies at that point? E1 is equals to EC plus delta ZC. That's it. Whenever you raise the bed, the relation between the energies are E1 is equals to E2 plus delta Z. But at critical condition, delta ZC EC. So what is E1? Y1 plus V1 square by 2G is equals to 3 by 2 YC. What is EC? YC. 3 by 2 YC, which is 3 by 2 Q square by G whole to the power of 1 by 3 plus delta ZC. Now how to find out the V1 value? So V1 value, they haven't given the V1 value, right? But you can find out the V value. So how to find out the V value, sir? V is nothing but discharge by depth. If it is a V1, then discharge 2.76 by 1.524. So now you can find out the V1 value. So what is V1 value? 2.76 by 1.524. So now this will becomes as 1.811 meter per second. Now simply substitute over here. So Y1 1.524 plus V1 1.811 square by 2 into 9.81 is equals to 3 by 2 into Q square. What is this Q square? 2.76 square by 9.81 whole power 1 by 3 plus delta ZC. So now you can see, so V square by 2G 1.524. Now 1.691 is equals to, you can get the answers. So 1.378 plus delta ZC. So now you can find out what is the delta ZC. So if you solve, the delta ZC is going to be 0.312 meters. If it is asked as a rounded to one decimal, then you can consider it as a 0.31 meters also. So again, the concept is very simple. See, substitutions, you have a calculator, you can solve it. Concept you need to understand. Okay. So we covered the topics of channel transitions, we covered the topics of the hydraulic jump, and we covered the topics of the like a uniform flow, and we have seen some MSQ questions. So these are the topics that are related to the open channel flow. So that's all with this session. Okay. So if you have any doubts, you can message me, and all the best for your examination.